reading everyone's favorite colors and the gifts that you all shared. Much appreciated. Excellent. Excited to talk about functions and parameters today. I wanted to briefly talk about, we are moving on from one module to the next. So as you all will know, we were just talking about control structures. So that was our if statements or different conditionals, using our loops and iteration to control the flow of our application. We're now going to move into first talking about functions, what we're doing today, and then we'll talk about some new data structures that are a bit more complex and also a bit more powerful than what we've used so far. So that's kind of where we're heading. Also, just sort of an overall arc. Perhaps you all know this incredibly well, and if so, then feel free to ignore me. But the goal, so where we're moving right now, is we're getting a solid foundation with JavaScript. And as part of our next module, we're going to start to really work on integrating all the different skills you all have learned. So applying the JavaScript knowledge in the context of HTML and CSS and starting to improve the web applications that you all are able to build, really joining all of this stuff together. So that is where we are heading. That's it. I just want to give you a little preview of kind of where we're going. Today, we're going to talk about functions or parameters. I will tell you in advance, there's a lot of stuff in this lesson. It's just a lot going on. So I'm going to do my best to make sure we can get through as much of it as possible. Please, though, please ask questions. If anything is feeling tenuous, confusing, it's just not feeling 100%, just A-okay, please ask some questions in live chat so we can make sure that we can really understand this concept as best as possible. All right, no need to stay silent and keep your questions to yourselves. It's much more appreciated if you can share them out. All right, let's go through our overview and goals and then get started. So in this lesson, we're going to learn about functions in JavaScript. As it says here, a fundamental concept for structuring and organizing code. We're going to understand how to define functions, pass parameters, and return values, as well as a couple other key topics that revolve around functions. So at the end of this lesson, we're hoping you are able to define and invoke functions in JavaScript, pass parameters to functions and use function arguments, and return values from functions and understand their significance. So that's the hope for today. First, start with some warm-up questions. We have a block of code here for y'all to take a look at. What do y'all think? What's the output of this following code? All right, we got some guesses coming in. Much appreciated. Excellent, excellent. Yeah, right. So we're seeing true here. So let's break this down a bit. So at the start here, we say let keyword I equals 4. We are then going to say for I, right? Modulo 2, or modulo is going to return back the remaining value of that. When we're seeing this modulo 2, we're almost always going to be checking for, is this thing even or not, right? So in this case, there's no remainder from dividing 2 into 4. That is 0. So we have our triple equal sign here, which is checking if 0 is equal to 0. Something interesting, I think, about this, sort of to recall back and note, is that we're taking all of these different data types, right, and this strict equality, and it's transforming things into a Boolean, right? So this is one way of many is that we've seen data types getting transformed into another data type based off of some sort of brief algorithm. All right, let's complicate it a bit. Add in some of our control flow work. What would be the output of this code? Right. Thanks all for throwing those guesses. Appreciate it. It's all right. Omar, Juby, Dragos. Exactly right. 5 is odd is what we're going for. So we're still doing this check to check for even or odd. Our value though now is 5, right? And so this conditional is going to check just like we did before. If it's even, it'll return true. That means we'll go inside of the first part of that if statement. Otherwise, if anything else happens, we're going to get kicked out and go over to this statement where it says 5 is odd. Nice job, y'all. All right, one last one. Let's merge in some loops into this. continues to grow in excitement and complexity. What would be the output here? We've got some guesses coming in. Thanks, Asari. Thanks, Omar. Thanks, Ragosh. Thanks, Joseph. I love seeing that several people are typing. Thanks, Julie. Yeah, folks are picking it up. Much appreciated. Right, so what we're going to see here is that the first number that we start our loop with is going to be 1. Our condition here for our for loop is while I is less than or equal to 3. Right, so the equal to part is important. And then we have I plus plus at the end. That means I is going to be 1, 2, and 3. We then run this same check as before, and then we're going to print out whether 1, 2, and 3 are odd or even. So we have 1 is odd, 2 is even, 3 is odd. We could, of course, increase the values here or change them up to sort of change what the count is. But either in this case, we're just going to count from 1 to 3 and run that check. Excellent, y'all. I do have to sort of just call out, we've come a far way from just barely being able to type console log, right? We're now adding in, of course, our console log statements. We have conditionals running. We have for loops running. And this is feeling even just kind of like moderately good. Please take that as a win. This is a lot of content to learn. And it's certainly quite tricky. So well done, y'all. All right, now that we recall all of our various sort of control flow content that we talked about, let's talk about functions. So as I mentioned, this lesson is going to be pretty detailed. I'm actually going to just go through this first slide of introduction to functions, and I'm going to jump down to function declaration so we can look at the syntax of it, and then we'll bump back up to some of the more definitional aspects of functions. So let's talk first about what functions are. We have this nice little image right here. We can see some input comes in. We have a little function, almost looks like kind of like an engine kind of thing, and then we get some kind of output. A function is a reusable block of code that performs a specific task. Think of a function as a machine in a factory. You put something in, inputs, the machine does something for you. That's processing those inputs, and then it gives you something back. Functions will enhance our code by encapsulating code. They provide modularity, so they can break down more complex problems into smaller, more manageable pieces. They allow for reusable chunks of code, which is really useful. And they're going to be able to help us with abstraction, which sounds like a head idea, but really is just the idea that we're going to sort of pull away some of the complexity that we've seen in some of our code bases as they've been growing. Think of the project we talked about on Tuesday, right? I was adding in some more features with loops and conditionals and all kinds of stuff. And even though the code was getting to a place where it was working nicely, there was a lot of it, right? That's the kind of code that we can really improve with the use of functions to make it more readable to humans. One thing that's important to note is that functions are really a design tool for us as developers. The computer doesn't necessarily care how you write the code, right? It just needs to know what instructions it needs to perform. But as humans, it can be easy, as we saw on Tuesday, where I was copying and pasting around too much and made a mistake, right? It's really easy to make those kinds of mistakes. And so functions is one way for us to be able to better talk about code and more easily reason with it. All right, if you're following along, I'm just going to jump down to function declaration because I think the encapsulation, modularity, reusability chunk will make more sense if we have a bit of a definition here. So let's start with looking at the syntax of functions. So functions will look like this. Function declarations are used to create named functions that can be invoked using their declared names. They consist of these 4 parts. We have the function keyword. We can see that right here, right? This is the function keyword. We have the function name, right? And that's going to be the name right here. You'll notice it's still following sort of the camel case format that we use for variables. We have an optional list of parameters separated by commas and closed within parentheses. We'll talk more about parameters in just a bit. That is the parentheses you see right here. And then we have the function body. We've seen this sort of like code block multiple times, right? Where we have our curly braces and then we have lines of code inside. You can have one line of code, you can have multiple lines of code, no limit in terms of the size of your functions. So that's the basic structure of it. So to step through this a bit more slowly. So the function keyword is a fundamental part of the function declaration in JavaScript. It is used to define a new function and indicates the start of the function declaration. This keyword is followed by the name of the function and the function body. So if you're wanting to use a function declaration, which is this style of defining a function, you'll need this keyword. The function name should be something that, first of all, follows the camel case convention that we followed with all the rest of our variables. And ideally, it's also something that is clear what's going on, right? So in this case, this function says hello world. It's going to print out hello world. You want sort of action-oriented functions, as it says here. It should be descriptive, typically using camel case, and often starts with a verb to indicate the action the function performs. So functions are really actions we're performing in our code. So sticking with some kind of verb is best. I would even say we could rewrite this to say hello world or print hello world. That would be even more clear than what we're looking at here. The parameters that we can add into a function, we're going to be able to define how many parameters there are and then what we use those parameters for. Parameters are going to go in between these parentheses. You can see sort of an example down here of an add function, which might take A and B. You can define the names of those parameters that get passed in, and then when you use that function, you'll be able to reference those names to perform some kind of operation. Think of when we've used, what did we do? I guess on Tuesday we used like .repeat, right? That was a method. We passed some value into the parentheses. That is some value that we passed in, and under the hood would be a parameter, sort of the number of times you're going to repeat. We'll see some examples of this where I think this will get clarified a bit. And then we have the function body. So that's everything within the curly braces. You can do whatever kind of JavaScript code you want in here. And again, it can be any length. It can be a line or a few hundred lines, although it may not be the best design, but one could. All right, so let's take a look at an example now. We talked a little bit about the structure of this. Let's take a look at an example. Up here, let me make this a little bit bigger. Slide some stuff over here. Okay. All right, so we have a function defined here. You'll notice we're using the function keyword to start it off. And then we have a name for the function. That name of the function is determine age group. So notice that we're, first of all, start with a verb, right? We're determining something, we're doing some kind of task. And then we're following camel case for the rest of this, determine age group. We then have one parameter. That parameter is called age. We could call it whatever we want. Just to be clear, it doesn't have to be this. We could call it whatever we want. We then have our curly braces. And within these curly braces is our block of code. You can see within here, we have a conditional statement, and we're sort of checking to see, hey, is the age less than 13? Is it greater than or equal to this, et cetera, right? And depending on the value, we're going to print something out. Okay, so a couple of details on this. First of all, where does this age value come from? Well, it's referencing whatever is passed into the function. It's referencing this parameter up here. How does something get passed into this parameter? Well, like we saw with .repeat, I'm trying to think what else we want to pass something into. I don't know. We'll have to, I'm sure, look into it later. What we'll need to do to pass a value into age is we need to invoke this function. You also may hear about it as we're going to call this function. This code on its own is just defining the function. Nothing is actually happening yet. Our program is not running any kind of calculations. We're setting up our little machine to run in the future. So as an example of that, let me go ahead and run this code right here. So take a look at what we have here, right? We have function declarations wrapping around this code. What happened? Nothing, right? We're just running some code, no output. So why did that not happen? That's because we're not invoking and we're not calling the function. So just defining the function is not enough. To call the function, to invoke the function, we need to call it by name. And then we'll want to put in some parentheses. You all have seen this structure a few times before. You've actually seen it with console.log, right? We have something kind of similar here where we're passing some values in. When we call this function, because a parameter is expected, we want to pass in a value. Before I do that, though, let me just show you what happens if we just run it. And actually, let me do a couple things. First of all, if I just type the name here, if I just reference that function, nothing's happening, right? Just referencing the function name is not enough to actually have it do something. We actually need those parentheses. These parentheses are the things that say, go for it. Go ahead and do the action I've asked you to do. Now, when I run this, I'm getting the value senior here. So let's just keep that in mind for a second. I'll talk through why that is as we enter in an actual value inside of here. So now let's go ahead and say 50. We'll put 50 in here to determine age group. This is the argument that I'm passing in to our function. When I run this code, we go ahead and get adult. So let's step back and walk through exactly what's happening here. Maybe this is obvious to you all. I just want to make sure we're all on the same page here. So two things are happening in this code. First thing is we're defining this function. The second thing is we're calling that function. In order to call the function, we need our parentheses right after the name of the function. We then pass in an argument. This value, 50, how the program works, how JavaScript works, is it says, great, I have 50 as an argument. I'm going to go take a look at the function definition here. Age becomes that 50, right? We're passing in the value. This is similar to us saying, if we had the code down here, right? Passing in 50 is similar to us saying let age equals 50. That is what the JavaScript is doing sort of behind the scenes here when we pass in this value. So the number 50 gets passed in. It is assigned to the variable name of age. And then we run through the code that we have here with access to age. So we're just passing in a value, and then we access it within that function value itself. Why this is pretty nice is because we can then call this a few different times. Right, so I can determine a few different age groups in my code and run all of these. Everyone's an adult, fantastic. And I don't have to reduplicate this code, right? I don't have to have these if statements all over the place for each one of these values, right? I'm just referencing that function up above. Let me pause here. Any questions on this? I'll talk again about why we got senior first in just a second, but any questions about what we've talked about so far? All right, folks, feeling good. We'll see. It's going to get better or worse depending on how you feel about it. All right, so let's talk about why when we first called this function, we didn't pass anything in that we got senior down here. So what happens when you all define a variable but do not assign it any value? What default value does that variable have? What default variable does a variable have in JavaScript if you don't assign it any value? You got that set where people are typing. What do you think? All right, we got not a number, null, undefined. Let's go ahead and check it out. Here's one nice thing about coding is it's nice to guess. I think it's fun, but we don't even have to. We can just see what happens. I'm gonna go ahead and log out what age is at the top of this function when we don't call it. So let's clear out our terminal, go ahead and run this. Check it out, age is undefined, right? So by default, if we define a variable and don't assign it any value, that value is undefined. This is the same thing for defining a parameter. If we don't pass anything into that spot, it's going to end up being undefined. And so what happens here, and I'll jump into our little no terminal here. We say, hey, is undefined less than 13? That's false. Is undefined greater than or equal to 13? And undefined is less than 20, right? That returns false. So undefined goes through and tries to get compared to all these different values. We have just an else statement here, which says, hey, otherwise, just go ahead and print out senior. So that is why we end up down here with senior getting printed out. So a couple things I think are kind of interesting, I should say, about this, and actually interesting as well as in terms of what you all put out. So one thing is that JavaScript doesn't know what data type this is supposed to be. We know that we're expecting a number in here. JavaScript has no way of knowing on its own, is this supposed to be a number, a string, a Boolean? It does not know. It just accepts whatever value is placed in there and will try and run the code for you, right? It's also, there's nothing special or unique in terms of how functions work to assign it some different kind of value. It's just working just like a variable, right? So this parameter here, you can just imagine it's just another way for us to declare variables that are special and unique to functions themselves. All right, let me try one more thing here. What do you think if I pass in 2 values here? What do you think is going to happen? Anything different will be the same. This is how you would pass multiple values into a function invocation. In this case, though, we've only defined one parameter up here. Do you think there would be any difference to what the output would be? Excellent. Thanks, Dragosh. Maybe it runs it for both of them, right? It says adult, adult. Any other thoughts, guesses? All right, got some people taking some guesses. Yeah, I can't tell you how happy it is. And people just go for it. If we're just gonna run it, it'll be fine. There's no wrong answer necessarily here in the sense that you're gonna be punished or something. All right, let's go ahead and run it and let's see what happens. All right, in this case, we're just getting adult once. Interesting, right? I love these sort of like guesses here. Maybe we get an error, right? Maybe we would get it to run twice. JavaScript is more chill than that. And by chill, I don't mean like really cool. I mean more like it's just not worried about it. It's not stressing. There's an extra argument getting passed in, whatever. Let me not worry about it. So because we've only defined one parameter up here, that's the only one it's worried about. If we pass in other values into here, it's just going to ignore them all. It's just gonna say, I don't know what that is, so I'm not going to worry about it. So functions will only use what you've defined them to use. They're not going to do anything extra, just exactly what you've told them to do, which I think actually ends up being a benefit. It means we know exactly how it's going to work. It's not going to make any assumptions about how our code wants to work, but it can be a little bit surprising. I think that it just doesn't do anything. It doesn't throw any errors. It doesn't throw, doesn't do anything special with them, nothing at all. This is, I would say, not 100% unique to JavaScript, but somewhat unique to JavaScript. JavaScript is a very flexible, go with the flow kind of language. Other languages you all might use, Java or Python or some other programming languages, will be more restrictive about if you define a function this way, it wants you to use it in that exact way. There are pros and cons to that for sure. But in this case, you could think of JavaScript just like, great, I'll use what you tell me to use, and I'll just ignore the rest of it. All right, excellent. Cool. Let's move on and give you all something to do now. So I'm going to ask you all to go ahead and write a function. We love converting temperatures here, right? Is it Fahrenheit? Is it Celsius? What's going on? It's always a fun time. So we're going to ask you all to write a convert temperature function. We have our description right here. So we want to write a function declaration named convert temperature. It takes 2 parameters, a temperature value, I'm giving you an example variable here, and a unit. The function should convert the temperature from Fahrenheit to Celsius if the unit is F, or from Celsius to Fahrenheit if the unit is C. So essentially, you're going to give it a some value, some particular temperature value, and it's going to convert it to the other value. The function should print the converted temperature in the following format. You can see that right here. So converted temp, got this little degree symbol and then target unit. And then here are the different formulas for Celsius to Fahrenheit and Fahrenheit to Celsius. And an example of the syntax down here. So let me go ahead and let me get you all started, and then I'll pass over to you to just spend a couple minutes and try to work it out. So when we look up here, we see we have write a function declaration. It means we're going to need the function keyword, right? And it is named convert temperature. So notice here we have a verb, right? And it's pretty clearly describing what it is we're going to do. I'm then just going to set up the function frame. I feel like this is always a nice way to start. This function is going to take two parameters, a temperature value, and it's suggesting we use temp, and a unit, and it's suggesting we use the word unit. We'll then need to run some code that's going to check for these values, decide which way to convert the value, use this algorithm, right, to convert that value, and then print it out in the following format. So that's the part you want to complete in the function body, right, within here. Down here, after you define your function, you'll need to call your function somehow. So remember, you'll want to call that function name, have parentheses, and you need to pass some values into it. So there's a bit of a frame of what this will look like. Let me pass over to you all. Let's take 2.5 minutes or so on this. If you get to a good spot, let me know in chat, and maybe we can accelerate or take a little bit longer. Any questions on this before we get started? All right, we've converted some temps a few times. Excellent. I'll go ahead and throw up 2 minutes or so on a timer up here. Go ahead and get started. Thanks. I might give everyone a few more seconds here. How are folks doing on this? Doing good? Need another minute or so? Sorry to interrupt you if you're busy. You got it, thumbs up. Thanks, Aaron. I appreciate it. All right, let's do this. I'll very slowly start to walk through this. If you're a question ahead, please feel free to ignore me and just continue coding. Better for you all to be coding than listening to me yammer, right? All right, so let me walk through how I might think through this. So we have our structure here of what we want to do, which is helpful. In this case, we need to figure out how to do this conversion. And remember, we first need to figure out the direction of the conversion, and then we'll actually need to run that code. So the first thing I think we want to do is check something about the unit, if it is Fahrenheit or Celsius. Let's go ahead and we'll say if the unit is Fahrenheit, do something, otherwise do something else, right? So in this case, this first case, if the unit is Fahrenheit, that means we're converting from Fahrenheit to Celsius. So thankfully, we can actually just look down here and they've figured this out for us. So Fahrenheit to Celsius, I can just copy this over. And we say converted temp, paste that in. And then we need to log out what the value is. We also have this helpfully right here. So in this case, we'll know what the converted temp is. I'm going to use template literal here to run this. And then target unit, in this case, we know we're going to go the opposite. So this should be 2 Celsius. All right, let's actually pause here and just see if this part works before we finish in the next part. Omar, I love the question. Let me get to it in just 1 second here. So in this case, in order to run this, right, we're going to need to invoke the actual function. We also need to check some values in here as well. So for Fahrenheit, let's go ahead and say 50 Fahrenheit, and then see what we get. Ah, amazing. Do y'all see what I did wrong here? What do y'all think? Do you see it? It says here reference area convert temperature is not defined. Sometimes I like just lingering on these issues because I feel like I'm sure you're gonna get it at least once. If you never get any errors though, let me know. I wanna shake your hand, fly out to wherever you are. This is probably a pretty common error that might show up. All right, so we got a guess. The function did not return anything. Thanks so much, Joseph. All right, so if the function doesn't return anything, that should actually be okay. Yeah, Tuma's got it. I just spelled stuff wrong. It's just fat fingered it, right? And a very normal part of just software development is just typing things incorrectly constantly and being like, duh. All right, excellent. So in this case, usually if it says reference error, that means it can't find the thing that we are trying to find. And I'm going to say most of the time, that means we just spelled something wrong, particularly as we're getting started. All right, as we run this, all right, so we can see that 50 degrees Fahrenheit is 10 degrees Celsius. Oh, sounds right to me. It's pretty chilly. It's about right for 50. All right, excellent. Now, if we want to do the same thing for Fahrenheit, we're going to do basically the same code down here. We're just going to change up what the algorithm is. Oops, gotta grab the right one here. Excellent, and then we'll change that over to Fahrenheit. And so in this case, 50 Celsius, I think it's going to be a little bit different than what we were looking at before. Let's go ahead and try that out. It's 122 Fahrenheit. Oof, oof, that's hot. All right, so what we're looking at here is we have our function, right? We've called it, we passed in correctly the two arguments here. They're defined up here as part of the function definition, and then those variables, those parameters, are used throughout to complete this little algorithm here. And again, what's nice here is that we can run this multiple times and get different results depending on the inputs we put in. Cool, right, so a couple of questions that came up and just a couple of the details. So one thing you might notice is I'm switching between using the word argument and parameter. So I would say you might hear them spoken interchangeably. Sort of if you're reading something, they are sort of speaking about the same thing. Often we'll talk about a parameter. I'll try and use the word parameter. I'm talking about the function definition, what might also be called the function signature. We're talking about the parameters that are defined up here, what's in the function definition itself. We're talking about an argument, pass-in arguments, that's often part of the invocation itself. Just a slight word difference that you might notice, which sometimes actually can be helpful to distinguish when talking about code. Ultimately, we're talking about what values, what inputs do you put into your function, and how are those inputs used within the function. That word input is really referring to these arguments, these values that are passed into the function. Now, Omar asked a great question of what if the input is neither Celsius or Fahrenheit? Should we account for that possibility? And here you start to see the wonderful world of diving into rabbit holes of, oh goodness, how is someone going to use this function? Because what could happen here? Well, in the best case scenario, our user, our developers, we know exactly how this function works and we use it correctly every single time. But what's going to happen here if, let's say I want to convert 50 Fahrenheit, but I type in a lowercase f, right? It's actually going to switch it over to the Celsius side of things because lowercase f is not the same as uppercase f. What if we type in here Celsius? Well, that's going to do Celsius as well, but not because we typed in Celsius, just because that's our else case, right? We just type in some other string, what's going to happen? It'll just go to Celsius. If we don't put a second argument at all, what's going to happen, right? These are a number of different sort of things we have to think about when we're writing these functions. A lot of problems could arise depending on how we want to use it. So a couple things I'll say for sort of thinking of this. The first is in terms of who's going to use the function, it's almost always going to be you and other developers. That's almost always going to be the case. Where you have to be more considerate about these different edge cases is whenever you're handling a user input. Because as we saw, first of all, users can do whatever they want. They just will play around and bust things on your website. But also as with user input, right, we were getting input, and even though someone was typing in a number, it's going to be coming as a string, right? So anything that surfaces, that touches your users, you want to be extra sort of protective and think about what kind of checks could we do to make sure the data coming in is what we'd expect is coming in. Internally, when you're just writing your own code, you can write these kind of checks to make sure, hey, is unit one of these like 2 values? Is temperature a value, is it actually an integer? But if you're just the one using it, it's probably okay to sort of not be so overly careful with checking every single data type. But if you end up making a mistake later on, it might be harder to discover that mistake. So it's sort of putting work in different places depending on what you want to do internally. As we'll see in probably a week and a bit, we'll start to work with functions and user input. And again, that's where we want to be extra careful of what we're doing. All right, I think I'll pause there. Any questions so far about this topic, this code, anything like that? Joseph, well done. Is here using our prompt sync. Very nice. Anything else feeling confusing or feeling uncertain? Let's see, a couple of folks typing, so I'm just going to give everyone a sec here. All right, feel free to keep typing, folks, for other questions. And I'll get to them in just a moment. All right, here we go. Just ask, in which scenario do we use return and which do we not? So we're going to talk about return in just a bit. So just hold on to that question, Joseph, and we'll talk about that then. And then we're asked, shouldn't the console log look something like this based on what the instructions were? So I'll paste that over here. So in this case, I think this will be the same thing here, right? So with these backticks, we are just passing out the converted temperature in here and choosing the correct temperature to complete to. I think maybe what you're referring to is this unit part, right? The unit bit is for us to check what the current value is that's coming in, at least as I understand it here. So let me reread this. So the function should convert the temperature from Fahrenheit to Celsius if the unit is Fahrenheit. So that says to me, if the temperature coming in is something like 50 Fahrenheit, that means we're converting to Celsius. So if we passed in the unit here, it would be the opposite unit as to what we want, right? Oh yeah, in this case, it's not defined because I was messing around, but let's pretend it is. So in this case, I'll plug in unit here so you can take a look. So if we're passing in 50 Fahrenheit, we're expecting the value that we get back to be Celsius. If I run this code, you'll see the value, the integer, is converted, but we didn't swap the actual label for it. So in this case, we're going to use the unit to determine what the value is coming in, and that's what's going to help us switch and decide which value we want to go to. And then converted temp, that's what we're actually using to print out. Yeah, no worries at all. So I think in this case, we can just define these explicitly. All right, excellent. We've gone through our function declaration a bit. We'll talk a bit more about calling functions. I do want to jump back up here now that we sort of see the outline of how functions work. Let's just talk about some of the benefits once again of using these functions. So if you're following along on Codio, and I was just in function declaration, I'm going to jump back up here to encapsulation. All right, so when we think about functions, they give us a number of benefits. One of those benefits is encapsulation. So encapsulating code means grouping related code into a single unit, such as a function, that can be used repeatedly. This approach helps in organizing the code, reducing repetition, and making it more readable and maintainable. So here we have something a bit mathy. No worries, you just have to kind of understand the concept here. So without a function, we have to write, let's imagine we have to write a formula for calculating the area of a circle twice, once for each circle. This leads to code duplication, increases the chance of errors. So we'll see below here, we're using sort of a special, what is this, special constant value within JavaScript called math.pi. That represents a way to calculate pi, this fundamental symbol, if you all remember from, when did we learn pi? Geometry? Is that right? I don't know. It's been a long time since I've been in school. All right. In this case, it's calculate pi. Hopefully, I'll remember that. Pi is the value that represents the ratio of the circumference of a circle to its diameter. It's approximately this long, infinitesimally long number. So anyway, this is what it would look like in terms of getting the area of our different circles. So we can see where we have our radius. We're using math.pi to represent that pi value, and then doing some multiplication here to get the area. And if we want to do this for multiple circles, we'll have to just repeat this code multiple times. If you're just doing it twice, maybe it's fine, but if you want to be doing this all the time, multiple times, depending on what your program you're trying to design, this could get annoying. The other thing I'll say too is as soon as I start to do stuff where I have like radius 1, radius 2, it starts to make me feel nuts, right? This to me feels like there must be a better way than numbering all of our variables. With a function, we can define some function and it'll encapsulate that code. It'll lead to a reduce of code duplication and make the code more organized and easier to maintain. So if we look at this example down here, we have calculate circle area. That's the name of our function. We pass in our radius. And then we just go ahead and run that calculation. We will get to this return keyword in just a bit here. But you'll see this is going to allow us to then, the result of this code looks a little bit different, right? We're not duplicating this statement multiple times. And we are able to sort of just pass in these values relatively easily. So encapsulation just means that we're able to take what could be a complicated chunk of code, encapsulate it, and then reuse that code multiple times. All right, modularity. I'm talking about modularity. This refers to the practice of breaking down a complex problem into smaller, more manageable pieces, often through the use of functions or modules, something like that, to just make it easier for us to understand. So let's first look at an example without some modularity. So in this example, we're writing some code to help with our meal budget for our trip to America. We need to account for tax and tip. Sorry, it's a pain in the butt for all of us. We calculate the total cost of the meal directly without breaking down the process into separate units. As the calculation becomes more complex, the code becomes harder to manage and to understand. So if we wanted to calculate tax and tip here, we got meal price, tax rate, tip rate, and our final cost is going to be something like this. It's not the worst, but it's also certainly not the best either. And then we have total cost of the meal. So with modularity, the idea here is we can actually break up each of those little subsections into its own function to make it a little bit easier to understand and easier to read. So we define some separate functions here. We have calculate tax, calculate tip, and then we have calculate total cost. Those are 3 different functions we can define. And you'll see for each of these, these are actually pretty straightforward and easy to read. So we have calculate tax, just 1 line of code, calculate tip, just 1 line of code, and then we have calculate total cost. In this case, we pass in all of our values, and then we can use these functions we've defined within this other function, right? And so our final result of our code looks like meal price here, and then we just pass in these values. Sort of a small bit of code. This may sort of feel a bit, I don't know, challenging to see the benefit here. But I'll say one of the nice things here is that we can sort of look at this code and it reads a bit more human to us. We can see what's happening inside of it. Okay, we got calculate total cost, we're gonna calculate the tax, calculate the tip, and then add all this together. It's a little bit easier for us to reason through, even if it doesn't really matter at all to the computer. The computer doesn't care about these names, but for us, it might be a bit easier to understand and read. So that's the concept of modularity. For reusability, we've talked about this a couple times, just another sort of facet of this, right? In short, by defining these different functions, we're able to reuse our code multiple times. So we saw this already. Being able to define up here some function and reuse it will shorten our code overall. In these examples, we're just looking at sort of functions with a single line of code, but you could imagine these functions getting more complicated, like the one we just wrote, and being able to reuse that is definitely going to be a huge benefit. The last one here is abstraction. This one's a little strange to talk about. It can feel a little bit heady, but I do really like this idea. So abstraction in programming refers to the concept of hiding the complex implementation details of a task and providing a simple interface to interact with. This allows users to perform operations without needing to understand the underlying complexities. So when we think of abstraction, one way to maybe think about that abstraction is, for example, you all right now are interacting with your computer through a graphical user interface. It's also called a GUI, right? You're clicking on things. You're searching for like a button, like a back button or a forward button. You can click on that. Computers didn't used to work like that. The first computers, you needed to type everything into a terminal to get it to perform some kind of action, right? So it's a very different interface than what we're used to. What a GUI does is it sort of abstracts away all the complications happening under the hood, so it's easier for us to work with. If you're deleting a file or dragging a file from one place to another, that's a much more complicated interaction, but for us, it looks very visual, right? It's very easy to parse through, read, things like that. Abstraction in code works kind of the same way. In this case, without abstraction, we have this idea of providing some kind of discount. So you can see the code here is not terrible, but there's a number of calculations happening. With abstraction, the idea is we can actually write some functions for that and then just write a function called calculate final price and just use that. The idea here is that as developers, if we can build our tools, we then don't have to worry so much about how the tools work. We can just use that tool as needed. It's a really powerful idea of if we feel confident calculate final price works, we don't have to worry about the guts of that. The computer can worry about that. Instead, we're building our own interfaces, our own tools to solve our own kind of problems. And this is when we've used stuff like dot repeat, like dot to uppercase, stuff like that. That is essentially functionality that the computer doesn't really care how we do that. And there is underlying JavaScript code under those functions, under those methods to get it to work. But we just get to use the nicely named version of it, right? And so that's the idea of abstractions. We're abstracting away some of the complexity so that as humans, it's easier for us to write our code. These four concepts that we've talked about, I would say it's helpful to think about and is helpful to frame why we would use functions. To me, this is the kind of thing that we can always sort of revisit. You all can jump back to it when you're, I don't know, thinking about applying for jobs or just researching sort of why it is we're spending so much time with functions. And it's helpful to get sort of a idea of how developers use functions different ways to solve some of these kinds of problems. We're also going to see these play out as we just start to use functions overall. But I just want to spend a bit of time talking about some of the high-level ideas of why we would use these. All right, we've gone through our intro to functions, talked about some of the high ideals of functions, and we talked about function declarations. I'm going to jump down now to calling functions. So if you're following along, go ahead and follow along here and click on the calling functions heading right here. All right, so let's get back to some of the syntax and functionality of functions. So as we saw, we can call a function using parentheses. If there are no arguments that need to get passed in, there's no parameters defined as part of the function signature, we can just call that function with its name and parentheses directly afterwards. So in this example, we have a function called greet. It says hello world, and then we can just call that with greet parentheses. One note here too, the syntax is just important. So you need all the opening and closing parentheses, no space between them. That is what will give you that output. When calling a function that requires parameters, you pass arguments between the parentheses of the function call. For example, consider the function add, which takes 2 parameters. Again, these parameters are part of this function definition, this function signature. We then use those parameters within the function body itself. And then to call the function, we need to pass 2 arguments referring to the values we're passing in, between the parentheses for parameters A and B. So for add, we're passing in 2 values. We can call the add function by saying add parentheses, and then pass in 2 values separated by commas. Commas are a way to separate different values like we've seen with console.log. All right, arguments are values passed to function when it is called, providing the necessary data for the function performance task. They are placed inside parentheses and separated by commas. In the function call, each argument corresponds to a parameter defined in the function declaration. So again, we can sort of see this working out here. So in this case, add, where we pass in 5 and 10, 5, the value 5 is assigned to the parameter A, the value 10 is assigned to the parameter B, and then we were able to use those values within our function body. All right, so we have an example here. Let's go ahead and run this. I don't know the way I can make this too much bigger, so I apologize. It's a little difficult to see. Hopefully you have it on your side as well. All right, not too bad, not too bad. All right, so let's take a look at this one. So we have a function here called calculate total cost. This is calculating the total cost of an order, including tax and shipping. All right, this might be the kind of function on some e-commerce site that might have been developed. We'll take in all these different parameters here, and then we're going to work with those parameters to create some new variables, and then we'll log out the total cost of the order. To invoke, to call that function, we'll need to use the function name down here, have parentheses, and then pass in each individual value, one after another. So in this case, the price of this is 15. The quantity of what we're buying is 10. The tax rate is 0.08. And the shipping cost is 5. If we run this code, we'll get the total cost of this order. Just a couple things to note here. One is, of course, once you defined the order of your parameters up here, that order must match the order when you actually call that function. Perhaps that seems intuitive, but I think sometimes just looking at this, it's not. Whatever you define in terms of the order up here must be included. Another thing is you can't necessarily skip over any values in between, right? We'll actually talk a little bit about this later, but if for some reason we didn't want to include quantity, we can't just not include quantity as part of the function call. That changes the order, right? Remember, we have to be really explicit with our computer to tell it what we want it to do. So we'll need each one of those values in there. Is there anything else I want to say about this? I guess the last thing I'll say here is this to me it looks a little confusing. Just looking at calculate total cost, 15, 10, 0.085. If we were to write this out maybe a slightly nicer way, we might actually say something like, what's the price here? Actually substitute that in. All right, what's the quantity? And substitute that in. You can sort of see where I'm heading here, then adding in tax and shipping cost. That to me is going to read a little bit nicer and be a bit more understandable than just a series of numbers. So you can assign values to variables and pass those variables into functions as well. And I would argue that's going to be a nicer way to be able to understand how exactly your function is working. Sometimes it's not needed. Sometimes if you just have like an add function, right, it's going to make sense. But I think it can be useful with slightly more vague or complicated functions. All right. I just want to see where we're at here. Yeah, we have an exercise right after this. Excellent. All right, so as we discussed, function parameters are optional by default. That means you can define a function with parameters, but call it without providing all or any of the arguments. If parameter is not provided an argument when the function is called out, it would be assigned the value undefined. So we were able to discover this on our own just a little bit earlier. So there's an example here of, in this case, for the Greek function, we're actually checking to see if it is or is not defined. So the check here says if name does not equal undefined. Put another way, if name is there, right? If a name has been passed in, we want to say hello and then greet that person by name. Otherwise, we're just going to say hello, stranger. And we can see that functioning down here. So we say greet Alice. The output is hello, Alice. Whereas if we just say greet, then the output is hello, stranger. You might have seen this on like a website you signed up for, or maybe like didn't provide your name yet. And it might just say welcome or welcome user, versus when you actually fill out your profile, it'll maybe say welcome your name, right? All right, excellent. Time for you all to do some coding here. So we're gonna write a new function called build address. It's gonna take 3 parameters, street, city, and zip code. Note that a zip code is an American postcode and they are placed at the end of an address. The function should print the full address in this following format. So say street, and then the actual street value, city, the actual city value, zip code, the actual zip code value. However, the zip code parameter should be optional. If it's not provided, the function should print the address without the zip code. So the couple examples we have here, I guess I'll copy this over so we can take a look. All right, cool. So here's the output we're expecting. And you'll write your code here. If we say build address and have all 3 of our arguments passed in for street, city, and zip code, it should print out this string where it includes all 3 of those things. If we just pass in 2 values here, it should just say street and city. It should not include anything within zip code, right? So we don't want to see, in this situation, a comma, zip code undefined, right? We're trying to avoid that situation. So that's the function you all are being asked to build. Any questions on this task before we get started? All right. How are folks feeling? This has already been a lot of content. Feeling good? Feeling, is it flames? Flames everywhere? Yeah, no, just gotta use your the one good brain you got, unfortunately. Not together. No, it's not that bad. I do love that gift, though. I'm going to steal that for later. All right, here's what I'm going to say. Well, I'll give you all sort of, let's say 5 minutes or so to work on this. Couple things just to keep in mind. So remember, the first thing we're going to do here, I'll write out some pseudocode for you all as you're working on this. First thing we want to do is define our function and build its frame. By frame, I mean sort of the structure of it. Next thing I want to do is define the parameters for our function. Next thing I'm going to do is do the coding, right? Just this sort of problem of, hey, might have 3 or 2 things. What do we do with that? That's actually stuff we've already covered, right? So even though we're adding functions here, once you're in the function body, you're just coding now, which I don't know, you can feel how you feel about that. But in that case, there's nothing new that's happening there. So do the, solve the problem, do the actual coding you need to do, and then just make sure you print out the output at the end. All right, let's take 5 minutes or so. I'll put a timer up And if you get it done, fantastic. Go ahead and post something in live chat. If you're struggling or have any questions, please let us know as well. All right, good luck, y'all. Give it a shot. All right, y'all. If you're finishing up, feel free to move ahead. I'll go over a solution here. I do want to say, I think in the past we talked about having like a strong foundation in JavaScript stuff. This is kind of what we're talking about, right? Everything we're doing inside of this function body is stuff that we've learned before. But as you're seeing, we're continuing to add more and more and more on top of it, right? So that foundation feels kind of shaky. It's all going to feel stressful. But what is nice about this is, although the function part is new, once we get in that function body, we're just trying to solve code the same way we were doing before. So all the practice we all are doing on the projects and sort of revisiting our old content, that's going to continue to help you moving forward as well. So we'll focus on the function part, but let's also function on the coding part as well. All right, let's follow this to its conclusion here. Let's build our build addressed function. As always, we'll need our function keyword. We'll then enter the name of this. And then I'll continue to build the frames or the parentheses and our curly braces. For parameters, I think it even says up here what exactly we want. Yeah. So we'll be passing in 3 things. We need 3 different names. Again, remember, you can name these whatever you would like. Trying to be really clear is helpful. In this case, we're going to define all 3 of these, which is street, city, and zip code. Once we're inside of here, we just need to figure out the logic, which is both the hardest part and the part that we probably have the most amount of practice with, right? So in this case, as some of you all are sharing, thanks Tatiana, thanks Joseph, thanks Omar, the first thing we might want to check for is zip code defined in any way? So there's a couple different ways we could do that. So we could say if, how did I type it? Zip code is undefined, then do one thing, otherwise do something else, right? This is the majority of the logic here, is just checking whether or not zip code is correct. If it is undefined, we're going to print it without the zip code. Otherwise, go ahead and console.log. I'm going to use our string interpolation here because I know how much you all love it. So let's get some practice with it. We got city. And we got street. And it should be basically the same thing up here. But we just don't have that zip code. All right, so we define the contents of our function and then print it out. Use build address to try out our 2 different cases here. Let's run our code. All right, not bad. It's looking okay. Pause. Any questions about writing this code, running it, coming up with a solution? It's just starting to feel kind of crunchy. It's like we started from like, hey, just define a variable, don't worry about it. And now it's like, okay, right, I gotta do if statement, and then I need the parentheses here, and there's multiple curly braces, and can start to maybe feel like a bit much. One thing I'll note too, and I talked about this, I want to say maybe Tuesday or Monday. Indentation here, how we write our code is really quite helpful. If I flatten all this code, I mean, I flatten is like do this. Ugh, this quickly gets more difficult to reason about, right? I can start to feel like you're just adding random symbols as opposed to building a structure. So that formatting, if you all have sort of been able to avoid maybe doing some of that, just kind of leaving things, perhaps a bit visually postmodern, a bit unique. Now would be a good time, I would suggest, to really start to say, okay, I have this curly brace, this is matching the one I here. I want to enter in sort of a line to make sure the stuff is spaced out. And hopefully our IDE in Codio, and if you all download one like VS Code, it'll do the same. We can actually see that the colors of these match, right? So the color of our function definition, these curly braces match here. The colors of our if statement here match. We see that for even our template strings, for our parentheses. So there is some nice ways that our IDE tries to help us out and reason through the code we're writing here. All right, I'm gonna keep moving. Either people are feeling good or are silently crying behind their blacked out faces. So either way, we'll keep plugging ahead. We do just have a few things to go over. Give me actually 1 second here. I just want to poke around at this. I just want to make sure the order here makes sense for you all, and we can focus on some of the less essential stuff at the end. Yeah, I think this could be fine. Okay. All right, I'm just going to do a quick adjustment here. So I'm going to jump down to a return keyword. I think that is going to be the next most important thing. And then these other 3 topics are important, scope in particular. But I think we can get sort of the foundational bits here done before we have to get into some of the really tricky stuff. All right, so we had a question earlier from someone, I don't remember, I think it was Joseph, about the return keyword. So let's talk about the return keyword. So far, our functions that we've written have been using console log to print something out to the terminal, right? So we can actually see what it is. In JavaScript, the return keyword is used in a function to exit the function, so end the execution of the function, and return a value to the location where the function was called. Return statement consists of the return keyword followed by some kind of expression, variable, value that will be returned. Here's one example. So we actually saw this when we were talking about some of the benefits, right, of using functions. We have our function keyword here, calculate area, width and height are our parameters. We multiply those together to get the area. Instead of logging it out, we use the return keyword. What the return keyword does is it takes the result of this expression and brings that back to where this function was initially called. So that allows us then to assign the value of calculate area, whatever we've done within that function, to this variable or anything else that we're using. So in this case, we're going to perform some left-hand assignment and take that area and assign it to a variable called area. We can then do additional things with this. We can log it out immediately afterwards. We could also use the area in combination with another function, right, and continue to pass values down and around. Okay, so the idea of the return keyword is that as opposed to just printing it out to the terminal where it will kind of be lost, return allows us to ask for that value and receive it as sort of the final result of our function, and then use it as part of our larger program. A function can have multiple return statements, but only one will be executed depending on the logic and conditions within the function. Because remember, return also stops the execution of a function. As soon as you return, the rest of the function does not run. If a function reaches the end of its body without encountering a return statement, it will return undefined. So if we don't use the return keyword, but still try and access a value directly from it, we're going to be getting undefined. The return keyword can be used to return any type of value, including numbers, strings. We're going to talk about arrays and objects. We can even return other functions. We'll just leave that out in space right now, but it can get interesting and complex in a very fun way. All right, so let's take a look at an example here. So in this example, we have a function here. This function is called analyze number. It accepts a number as a parameter, accepts a numerical argument. And then it's just going to evaluate that number and return something like negative, 0, positive, and less than 10. These are sort of toy problem kind of things, right? It's just giving us some information about that number. Each time it is returning that value, it's returning it back. So I'm actually going to comment out this code. So if we just had this line, I'm going to say let example 1 equal analyze number -5. When -5 is passed in here as number, we would expect it to hit this return statement. if I run this code, what do y'all think is going to show up to the right over here? What do you think is going to show up to the right over here if I run this code as is? What do y'all think? What do we expect? All right, we got several people are typing. Folks are thinking. Got a question mark, nothing? We got a nothing period. All right, let's take a look. Yeah, right, it's nothing. Why is that? Because we're not logging out, right? We're not logging anything out. So in order for us to see the output of that in our terminal, that's where we have this console log statement. We're actually going to print out that value. Now we run it, we'll see the result of it. Excellent. I'm going to comment the rest of this in. We can take a look what we got. So let's walk through these different options here. When -5 is put in, the string negative is returned. When the value is 0, the string 0 is returned. When the value 7 is passed in as an argument, that satisfies this condition of being greater than 0 and less than 10. So the string positive and less than 10 is printed out. And when we pass in the integer, the number 15, it does not meet any of these requirements. That means the function ends and nothing gets returned. By default, that means we'll get back undefined. So that is what we're looking at here. Okay, so maybe a question is why? Why would we do this? Well, actually, this is going to be the default for most of your functions instead of logging. While logging is useful for us as developers, of course, as users, I imagine until you took this course, you weren't regularly scouring the logs of any website, right? So typically we want to return back a value because we want to use that value to do something. Perhaps in this case, in the future, what we might do is if we were to use this function, perhaps the user enters in some number, we evaluate it, and then we take back that value, and we want to do something like print it to the page by adding an HTML element the user can see. Or based on this, we're going to change the color of something that's on the page. We're actually going to perform some kind of action with this. Typically, we won't be logging anything out. We'll actually be using that value to make some other kind of decision. So returning is actually, in general, what you all will be doing moving forward as you're actually writing these more complicated programs. All right, let me give you all a chance to do some coding here as well. We're going to write a function called calculate grade report that takes 3 numerical scores as parameters: score 1, score 2, score 3. The function should calculate the average of 3 scores and return a grade report string in the following format. So the output we're looking for is going to be something like average score and then a grade evaluation. Grade should be determined based on the average score using the following criteria: if it's 90 or above A, 80 to 89 B, so on and so forth. After writing the function, test it by calling it with different sets of scores and printing the results. And this is what we should end up being able to do by the very end and get something like this output. That is the plan. Real quick, how do I find the average? How do I find the average between 3 numbers? What's the algorithm there? Just in case anyone's forgotten, who can help us out and describe. Click on the draw there. I just love it. Yeah, right. So we're going to add those numbers together and then divide by however many numbers there are. So in the case that we have 3 numbers, we'll add them all together and then divide by 3. In that little algorithm there, right, let's make sure I would use some parentheses too. So if we had grades, we would say x plus y plus z divided by 3, something like that. All right, excellent. Let me give you all a few minutes. We'll take another 5 minutes here. I think we're doing okay on time for sure. So let's take 5 minutes. Go ahead and try this out. If you have any questions, let us know in chat. If you're crushing it, let us know in chat as well. All right, folks. How's it going? Was this a tough one? I'm gonna very slowly get started with a solution here. Again, if you're working on it and feel like you're getting to a good spot, feel free to just continue on. You can always watch this later or check in just a moment. So let's talk through maybe how to think about this first. So we'll need to define our function. We need to accept some parameters. And then we basically do a couple different calculations, right? There's two different calculations. The first is to get an average. And the second is to rate that average according to the grading rubric we have here. All right, so there's two different steps. So let's first just sort of start and try and follow exactly what it says here. So go ahead and write our function. We want a function with the function keyword. That's going to be called calculate grade report. And then we'll need three different parameters on here as well. It suggests saying score 1, score 2, score 3. Sure, I think that works just fine for right now. Then we have two steps here. We want to create an average, right? So that's going to be something here. And then we also need a grade, right? We'll need both those things. So right now, of course, it's not code. There's nothing special about question marks. I'm just sort of setting up the structure we have here. So for our average, some folks are able to help us out there, right? We want to add these values together and then go ahead and divide by 3. That'll be our average score. To determine our grade, what we'll need to do is do some sort of conditional statement, right? Based on this rubric. So there's a couple ways we could do this. I'm going to go ahead and define the variable up here, like grade, and then write a conditional afterwards. So we might say something like if average, because that is now the value that we're looking at, right? If average is greater than 90, I'm going to go ahead and set grade equal to A. Else if average is greater than, I guess I should say greater than or equal to both of these. Excuse me. Equal to 80. Is going to be equal to B. If is equal to 70. At this point, we're kind of just following the pattern here, right? Nothing too exciting. All right, otherwise, let's say grade equals that. And then down here, we can go ahead and return, actually, sorry, this statement, I should say. Right, this is the string we want to end up returning. So I'll use our template string here. And we can pass in our app values that we got. I think this should do it. Let's go ahead and run it and let's see. Let's see what I misspelled. I'm sure there's something. Okay, not bad. All right, so in this case, we got our average score and we got grade B. Did you all do anything different? Did you get any errors? What was your experience like? What do y'all think? Got something similar, different? Be quiet makes me nervous. Perhaps you're all just busy. You're just taking a look at my solution. What's my path? Wasn't the path? I get. All right, cool. Yeah, yeah. Talk to me. What's challenging about this? What do y'all think? If it's not hard, great. But I assume we're getting to the point, as I promised, that this is starting to feel like, oh goodness, what's going on? What did y'all feel like was challenging here? Shares Tatiana says, just remember the structure of it. Sure. Yeah. I think definitely like we're getting to that point where we're starting to add enough stuff. That's just kind of feeling overwhelming. Which tool to reach for? Sure, Jarvis says, I remember which exactly is the easiest way to do it and not go the most complicated way. Hey, I'll say if you can go the complicated way and get there, great. Whatever works. Don't no need to overthink it too much. I do think we're getting to this point where it's really going to be helpful for you all, and I'll try and do this as much as possible, to really walk through and comment out what exactly it is you want to do. Because I think if you just start coding, it's easy to get into a spot of being like, wait, what do I do now with this? Right? The thing we want to avoid is just doing pattern matching. What I mean by that is saying, oh, we're in the function lesson, so I need a function. Okay, let me pull that from somewhere else and plug it in and hope that works, right? Instead, the thought process I want you all to try and be internalizing is okay, what exactly is this asking me? Okay, well, it's asking me first to get the average. Excellent. Once I have the average, what can I do then? Right, actually trying to write out the steps there. So for, what I've been doing up here, I've been writing out sort of the steps of like, first write the function, next get the average. This is the kind of thing I would actually suggest trying to do as these functions are to get more and more complicated. I know it might feel like extra work, kind of silly, but having sort of a path to follow can definitely make this feel much easier than just diving in. When I'm working on some complicated coding solution, I need to do this as well. It's like a normal part of the software development process is to really step back and think about what it is we need to do, as opposed to being like, I think I can do a loop somewhere and something will work out, right? Totally very, very normal to have this as part of your process. So I feel you if that is the case. And I think I would guess the other challenge here is just we're having to reach for all these tools that we've been using a bit in isolation and having to use them much more quickly, right? So we're using functions and we're doing arithmetic and we're going to use those variables to pass in to an if statement, right? We're having to do everything at the same time. All right, cool. Seeing a couple of folks share a few things. Tatiana, I'm guessing you probably don't have backticks here for your return statement. It looks like that's the thing that's missing. Let me know if that helps out. If not, let me share your code. We can take a look. I do want to show you all one very small thing here before we move on. So remember we talked about earlier in terms of being able to break down our more complicated code into simpler code. This to me is actually a good situation where we might want to do that. So we have our function calculate grade report. You all can just watch up here. I might break this up because there's really two different problems we're solving here. We're first getting the average, and then we're accessing the grade. And in this calculate grade report function is really about calculating it and then returning it back in this format. So I'm going to write two new functions up here. First one I'm going to say is get average. And the next one I'll write is get grade. I should say get letter grade. Perhaps that's more clear. All right, and then I can move some of this code in this function I've written up to get average and get letter grade. So up here, I'll move our average code up here. I need to make sure to return this value. And then we'll need to pass up what those scores are so we still have access to them, right? So they'll still need score 1, score 2, and score 3. What will change down here then is I can use my get average function and pass in those parameters. So because I'm returning the value, I'll get access to it here when I invoke it, and then I'll have access to that as part of that average variable. All right, excellent. This one on its own, maybe this is helpful, maybe it's abstracting a little bit, kind of neither here nor there. This one, though, I think will make our function much easier to read. So I'm going to cut this code out, paste in here. We need to get our letter grade. In order to get our letter grade, what do we need? Well, we need access to the average. So I'll pass an average right here as one of our parameters. And down here, we can say const grade equals get letter grade and pass in the average. The last thing we'll need to do is, in this function, go ahead and return our grade after doing that calculation, which will allow us to then get access to that letter grade and pass it over to grade. Let's go ahead and run it, make sure it works and didn't copy something wrong. All right, looking at the same stuff. Excellent. Now, this I think is actually feeling pretty nice. If we just take a look at this function, we can read it quite clearly, right? We can say, okay, this function is going to calculate the grade report. We're doing something to get the average with these scores. Excellent. And then we're going to grab the letter grade from that average. And then I'll print it out using this template string. This reads pretty nicely. The other nice thing here is, for example, let's say we wanted to change how we're going to assign letter grades, right? It would be more lenient or more harsh. We can really easily find that because we've named it really clearly. Right? Imagine that this function is doing some kind of work that's double the length here or triple the length. Having these nicely named functions makes it easier to find some particular part of our function and be able to tweak it without having to rewrite all of our code. So there's some really nice benefits we can get out of functions if we can master them. That said, there's a lot of areas in which this could cause some problems. So for example, if I forget a return statement, grade's going to be undefined here, right? If I don't pass in the right number of parameters here, right, this can get tricky. So it's not always, just having more functions won't always be a benefit, but something to think about to perhaps make it a bit easier to read. Last thing, last bit of my rant on this. We're getting closer to the break, I suppose, as I talk through some other stuff. What I would say is it's worthwhile to think about how we're passing around some of these parameters. Something like this, where we're taking all the parameters from our initial outer function and just passing them into another smaller function. That can start to feel maybe a bit silly at times. It really just kind of depends on how you're writing your function. But this can be a really useful tool to clarify what your functions look like. Okay, excellent. I'm sure this is feeling like your cup is full knowledge-wise. We have gone through what I'm going to say are the most crucial parts of this content. And just to review that, we're going to go over some of these other bits here, but just to review what we have talked about. We've talked about function declaration, how to define functions. We've defined some of the reasons we want to use functions, some of the benefits they give us. We talked about calling functions, how we need those parentheses afterwards, right? We can pass arguments inside of them. And then we talked about the return keyword and how we can use the return keyword to access that variable result outside of the function itself, right? And use that for other values, as we're seeing right over here. Okay. We've stuffed a lot in this lesson, so I'm going to try and cover these last couple topics here somewhat quickly. I'll highlight how important I think these are overall, of course, and then I'll try and move us towards a break so we can get to this lab, so you'll have a bit of time to work on this as a group before we close out for today. Okay? All right, so take a deep breath. That is the majority of, I think, what you all really need to internalize and know is the content we had here. Let's talk about some of the other ideas that are in this lesson. I'll jump back over to our default parameters. So as we saw earlier, we were able to check for whether or not a parameter has been defined, right? Whether a value is passed in. JavaScript actually has a way to assign a default value to parameters. This is sort of a helpful tip, a helpful tool you can use when writing functions. So remember our stranger function from before, we were checking if something is undefined or not. In this case, you can assign default values to function parameters by, in the function definition where we're defining those parameters, define the parameter name and then set it equal to some value. If this parameter is undefined, it will take on that value. So we can see that here with our modified greet function. We say greet name equals stranger, and then it says hello name. If a value is passed in case of Alice, that is what will get used, right? So we ignore the rest of this. But if no value is passed in, if that parameter is undefined, we'll use the value that's been assigned here, the default value that's been assigned here. So say hello stranger. The order here is quite important. So for an example over here, we have this function called create person. We're accepting 4 different parameters. We got first name, last name, age, which has a default value of 30, and nationality, which has a default value of Swiss. If you're going to use default parameters, you want those to be at the end. Because what we're saying is these might be empty, right? Just like we talked about before, if you stick one of these in the middle, you'll have to end up doing something kind of strange to get this to work when you actually invoke it. For example, in this example, we have create person, first name, last name is after this age equals 30, and then nationality with a default of Swiss at the very end. So if we wanted to invoke this, we would need to provide a first name. And if we didn't want to pass in an age, we need to explicitly say undefined and then pass in a last name. So in general, the rule is if you want to use default parameters, always put those parameters at the very end of your list of parameters. Yeah, we can see the example right here. This is what we would need to, in this incorrect ordering, this is how we need to write it, which this is weird and unnecessary. Just sort of typing an undefined name. All right, let's take a look at an example here. This is basically our example from before with a couple different default parameters. So we have name equals stranger. We have greeting equals hello. Both of these have default values. So that means they're both optional. If we call greet with both values present, go ahead and run the code right here. We can see over here, we get welcome Alice, right? This overwrites, these are the provided values for greeting and name. If we just pass in name, our default greeting becomes hello. And we can see that up here as greeting equals hello. If we don't pass in anything, since both of these have defaults, we use the default greeting of hello, and we use the default name of stranger. And that fills in here. I would say these defaults, although it looks a little bit strange, this will really help you in terms of having to check whether or not something is present or not. All right, we have an exercise here. I think for time, I'm just going to go ahead and walk through this alongside you all. Maybe ask a couple questions so that we can keep moving here. So we're going to write a function called calculate tip and split. Let's go ahead and write that out. That's our function definition. It's going to calculate the total tip for a restaurant bill and split the bill among a group of guests. Function should take 3 parameters. So our first one's going to be bill amount. That'll be the total amount of the bill. We want number of guests. That'll be the number of guests to split the bill among, and the tip percentage. By default, we're going to set the tip percentage to 15. Function should print the total amount each guest needs to pay, including their share of the tip. All right, so for calculating the tip, actually I should do 2%. Here. Ooh, let me squeeze everything. Goodness gracious. All right, so to calculate the tip amount, by multiplying the bill amount by the tip percentage and dividing by 100. Does it want us to do? Maybe it does want us to do 15 here. Let's follow the instructions. All right, so we're going to say tip amount equals bill amount times tip percentage divide that by 100. Add the tip amount to the bill amount to get the total bill. We say total, so bill amount plus tip amount. And then we're going to divide the total bill amount by the number of guests. So we can return total divided by number of guests. That looks like it. Okay. So what we see up here is we have tip percentage and we're saying the default there. So let's create some test cases for this. So the first test case, calculate tip and split. How many folks are hanging out? So we got 17 people in here. Let's say we all go to a party. $500 for the bill. We got 17 people in here. And we're feeling generous. Let's give 20% tip here. We'll log out that first result. All right, so in this result, we're anticipating, we're passing in all the different parameters. That's what I should say. When we look at this, everyone owes about $35 for that meal. No, that's not bad. It's not bad. We could do it. Let's take a look if we do not pass in the percentage. In that case, right, we're going to default to 15%. So take a look at result 2. We're going to pay a little bit less. Isn't it worth it just to pay the extra like $1.50 so the person, serving us can make the extra money? All right, so in this case, we can see we appropriately allowed for and defined that extra tip percentage, right? If we pass it in, it'll take the tip percentage that we give it. Otherwise, it will use the value of 15. All right, so that is default parameters. So it's a little bit like an advanced tip, but it can indeed save you some time. All right, let's take a look at arrow functions. So we've been spending the whole time defining functions with function keyword and the name, parentheses, curly braces. What if I told you there's another way to define functions? Would you say, please, Wes, shut up. I just learned this first one. Please leave me alone. Well, I'm going to have to tell you there is a second way to define this as well. There's a new version, actually really not new anymore, but the version ES6 came out, I feel like this is like 10 years ago, maybe? Kind of looking to Veronica, does that sound right to you? I feel like it's been like a decade, yeah. I feel like it keeps getting referred to as like hot new version of JavaScript, but like it's old, man. It's we're living in the future now. So there's another way to write functions that are called arrow functions. They look a little bit different. I will say at this moment in time in the course, you could probably ignore arrow functions. You will not be able to ignore it once you all start learning React. So if this is feeling like a lot, you can let it percolate, let it, hang out for a bit, but we're not going to be able to avoid this forever. So it's an okay time to introduce this. So in JavaScript, arrow functions with one parameter allow for an even more concise syntax by omitting parentheses. So we can see an example here. Here's sort of the frame of it. We actually create the function by sort of defining a variable here. And then we just have the parameter name. We do this little arrow, so they're called arrow functions, so an equal sign and a greater than symbol. And then we have our curly braces, which represent the function body. And we can see here, this looks like something like this. Take X, return. And it looks like someone didn't indent properly here, but we have our curly braces that would wrap around that. So in this example, the double function is an arrow function, one parameter, returns the value of X multiplied by 2. If there's only like a line of code or so, we can make this even more concise. So in this case, we can take the parameters. If we have more than one parameter, we'll need parentheses here. And if it's just like one line of code, we can do what's called an implicit return. In order for this to happen, there should not be curly braces, and your return statement should follow exactly after these arrow functions. So we're taking a look at add here. This is the full add function, right? As opposed to what would be 3 lines and a few extra symbols. It's just this one line of code. Parameters are right here. We see A and B. We'll need those parentheses because there are multiple. And then we have A plus B. That's the value we're going to return, the result of that expression. So we can call add pass in 5 and 3. 5 becomes A, 3 becomes B, and then we return this value of A plus B all in one line. This looks very snappy and allows us to avoid the return keyword, allows us to avoid curly braces, but understandably, I would say looks a little bit more confusing than our function keyword declaration. All right, I think we have a couple, there are no examples here. All right, that is A-okay. Let me just pop up to one of these, and I'll just show you what this would look like if we translated this into an arrow function. So again, this is one of the newer ways to write functions. At the moment, you are welcome to stick with this declaration. At some point there, we're going to come back to this. So if I wanted to translate this getAverage function into an arrow function, I would first of all, as opposed to using the function keyword, define it as a variable. I'm then going to assign it equal to this arrow function. And I need to add in this arrow here. That's it. Thankfully, that's actually all that's happening. We can do the same thing right here. Let's get letter grade equals assign a little arrow right afterwards. Couple nuances here. So if we only have one parameter, we can even avoid the parentheses. You don't have to, it's optional, but you could. If there's only one line to return, we could try and make this even shorter. So from all of this code, since we're just doing this one line of calculation, we could actually write it like this, and this would work as well. I'll say, I think unless you're doing something really concise, this starts to make my head hurt. There's a lot going on right here, right? You can do it. It's up to you. But I like being more explicit. This to me reads easier. I know what's going on. Feels a little bit better to me. Personal opinion, but that's what I would share. So your arrow function is just another way to write function. There's no, wait, is this true? There's no particular benefit to using an arrow function over a function declaration. You can do basically all the same things with either of them. You can set default parameters. You can, have as many lines of code as you want. There's really not too much of a difference. Just a different way to write it. All right, that's our brief tour of arrow functions. One last thing that I'll free you from this function rant, as the case may be. This last one is pretty important, although I don't think we're really going to understand all of it right now. I think as we start to work on this, this will start to make more sense, but it's helpful for us to sort of discuss this just for a brief moment so we can talk about it. So you all will notice a few things when we've been working on these examples that I've been able to use the same variable name in multiple different places. All right, so if we actually go back and look at this student grade report, notice I'm saying const average here, I'm saying let grade here, and then inside this other function, I'm using const average, const grade, right? If we weren't using functions, remember we were first initially getting started with JavaScript, there would be a conflict there, right? We could only define that variable name once. And if we try to do it again, we would hit some kind of problem. The reason this works, it's not magic, it's called scope. Scope can kind of feel like magic in a certain way. So scope in JavaScript refers to the accessibility or visibility of variables and functions in different parts of the code. It determines where a variable or function can be accessed and used within a program. There are two main types of scope in JavaScript. I actually say there's three now. So I'll talk about that last little bit, but we can talk about these. These are the most prevalent. So there's global scope. That's going to be variables and functions declared in the global scope are accessible from anywhere in the code. They're defined outside of any function or block of code. And then local scope, sometimes also called function scope, variables or functions declared within a function are only accessible within that function. They're not accessible outside of the function. So we have a couple examples here, I think, in in this. So first of all, for a global variable, when you're writing stuff at the top level, just within the file itself, if I said something like let global variable, I'm a global variable, this function has access to it. You can think of it as the function can look outside of itself. It can look up to find that variable. Whereas inside of here, inside of the function, that's going to be tied to that function. Code outside of the function cannot access that local variable. Let's take a look at this example here. All right, so we have a function here, an arrow function here, I should say, and a couple of variables. So we have let global variable up here, says I'm a global variable. And then we have a function, global variable function, that logs out that variable. Let's take a look at what happens here when I run this code. Okay, so we get two console log statements printing out this string. Why is that? Well, what this is demonstrating is that this function has access to the variable outside of it. It has access to it. So notice there's no parameter here that we passed in called global variable, right? There's no parameter there. So global variable is looking up, it looks outside of itself, finds that that variable does indeed say something and pulls that value within. We call that function, that's where this first global variable shows up. And then we log the variable out separately, that's where this second string shows up. In contrast to that, let's take a look at local scope. In this example, at the very top, we have a local arrow function. Inside of here, we define a function. We define a variable. I'm talking a lot. Inside, we define a variable called local var. It says I'm a local variable inside the arrow function. We're then going to log that out. That's the role of this function. We then call that function. When we call that function, it's going to print out this string. I'm a local variable inside the arrow function. When we try and access that local variable, though, outside of the function, we will not have access to it. So I can run this code here. Sorry, let me slide this over a bit. Yeah, so we can see here, it's giving us a nice error. It says reference error, local var is not defined. So why is that? That's because it is defined inside the function, but our external scope, the scope outside of that function, does not have access to it. It can't reach in to grab it. So we're talking about function scope or local scope. We're talking about variables that are only accessible within that function. We're talking about global scope, variables that are accessible outside that function, everywhere around it. That is the brief description here for scope. I think there's like way more to say. Here's what I would say though, more generally. In general, another type of scope is called like lexical scope. One way to think about it is whenever we have curly braces, this is almost always true. It's not going to be true with objects. There's a couple exceptions, but it's almost always true. We have curly braces. The variables you define within those curly braces are not accessible outside of those curly braces. This is another way to think about it. It's going to be true 80% of the time, 85% of the time. You're only going to be able to access that. So if I have a function here, let's say greet, and we'll say something like name. Let's say we're not going to use our default parameters. We'll say something like if name equals undefined, then we'll log out. We'll look to stranger. Otherwise, that a name. Okay, pretty straightforward function, right? So in this case, because we have this parameter within here, we can access name within the curly braces here. If I define something else here, like greeting, this is accessible within everything below it, basically, right? So it's accessible with the rest of the function, but it's not going to be accessible out here. Let's go ahead and figure this, and then let's check it out. Okay, so we can see that we do get this console log statement. It's happening right here. And then we get this error, just like we saw, right? Because greeting is defined inside of greet. We don't have access to that outside of here. This is what we saw so far, right? Okay. Inside of here, let's go ahead and move this down a level. And then what I want to do is mess with all of this stuff. So let's say greeting plus stranger. And then here we'll say greeting plus or name. All right, let's try. I'm going to do one more example here where I just don't pass anything in here. Let's clear this out. Let's take a look at what happens here. Perfect. Perfect. All right. What we're seeing here is we see our greet keyword. The first time through, when we call this function, we don't pass anything in. So what does that mean? That means name is undefined. Excellent. We get inside of this if statement. We then define our greeting, and then we console log out greeting, comma stranger. We see that did indeed work up here. In the else statement, when we try to greet myself, we did not define greeting, right? Greeting is not defined within these curly braces. And that's where we get this error of greeting is not defined. That is because this variable is tied, it's called lexical scope, is tied basically to its code block, its curly braces. So this greeting variable is trapped within here. So if we want greeting to be accessible to both of these, we need to move it up a level. Right, we need to move it up a level so that both of the code blocks within this if statement have access to that variable. So there's much more to say here with scope. I think it's an unfortunate reality. There's so much to cover here that we had to stick this into the function lesson at the very end. But I will say, if you're feeling confused about this, the way I think is easiest to think about this is with these curly braces. If you're defining something within a code block, it's going to be stuck inside of that code block and everything below it. If you want something accessible outside, you're going to keep pulling it up. You're going to sort of pull up the scope of this thing. That is sort of the rule I would sort of follow right now. Again, for the majority of the time, that's actually going to work for you. There's some cases where we're using curly braces where it's not going to make sense, but we'll talk about those soon. All right, goodness gracious, so much that we talked about today. I know today was jam-packed. A question from Omar, is there a particular reason I would want to have access to a variable only within a function? Yeah, so I think that the reason there is, one is just code quality. It's much easier. You're going to find trying to find new variable names for every single thing in your program is a pain. So some of it just allows you to be a bit more concise and allows us to do things like we did here, where we could reuse some of the same words like average and grade without having to come up with new variable names like average for average function, average one, right? Which actually makes things more confusing. So just readability wise, that is one reason. There's also some other reasons in terms of trying to make sure that the scope doesn't overlap here and you end up with some oddly assigned values. Those, though, I don't have an example for that. So right now, I would say code quality is one of the key reasons to look for that. Okay. I think now that we're basically at the end here and we only have about 20 minutes left, what I'm going to do is let's go ahead and we'll take our break now. Let's take just like a 5-minute break if that's okay. We'll come back. I want to just walk through the lab with you all so we can talk about just how it should go. And then we'll be on for the remaining time here, but we can sort of close out with just that. And if we have some time next time, I can try and go over this lab before we get started on the other content. I'll take a look at that content. So let's do that. Let's take a 5-minute break real quick, and then I'll see you all in just a bit to talk about the lab. All right, awesome. Thanks, Lon. All right, a quick break. Hopefully we're able to stretch. I think I cracked my back in a way that made me feel concerned. I hope you all got a good enough stretch as well. All right, let me share my screen here. So I think what we'll do, let me just walk through this, do a bit of a summary. And then again, we can stick around until 30 minutes afterwards. But once we close out, as long as we go through the announcements, if people feel like they want to, take a little bit longer of a break, I totally understand. I just want to make sure you all are set up to get through this lab so you can get it completed. All right, excellent. So our plan for the lab, we're gonna write a movie rating classifier. I told you all this is gonna ramp up in speed, right? And we're getting there. We're getting to the fun part of the ride here for JavaScript. So there's two things we're gonna do with this lab. The first is we're gonna write a function. The second is you're gonna write a loop that's gonna consistently prompt the user for some sort of value and then have some way to cut out of it. So let's walk through that. So this program is going to classify movies based on the ratings. Your program should, first of all, using arrow notation, include a function called classify movie that takes a single numerical rating as a parameter, returns a classification based on the following criteria. If it's 9 and above, outstanding, 7 to 8, great, so on and so forth. All right, before we overcomplicate it, let's just talk about that frame and what we want to do. So what we're being asked to do is create a function that is using that is an arrow function that takes one value. You can call that something like rating, and then we want to classify that value. You have an example of this in our lesson, right? We did this with the grading thing before, so we actually have an example of how this might work, although it's a different rating system. All right, so that's thing one. The next thing I want to do is use a loop to prompt the user. You'll see we have our prompt function up here. Prompt the user to enter a series of movie ratings one at a time. Call the classify movie function for each rating, and then print the corresponding classification. So a different part of our loop, or a different part of our program, I should say, has some kind of loop. I'm going to suggest a while loop, this while true loop that we talked about 2 days ago. We're going to do something where we prompt the user for a movie rating, call classify movie function with that rating, print the classification. And the last thing we want to do is continue the loop until the user enters a specific keyword. For example, done to stop the program. So that could be something, this could actually be like 0 or 4, however you want to do it. So you could say something like check if the user encoded done, and then cancel. I guess actually this would go right after the prompt, right? So this is one subpoint A, something like that, right? So those are the steps of what we want to do. Remember that in terms of breaking out of the loop, we have the break keyword, which could help us do this. Okay, so let's look at an example here of what this might look like in terms of the output. It's kind of a very slow build program, but we get an output that says enter a movie rating or type done to finish. The user enters something, and then we print out what that classification is. We continue that loop, continue to ask for a movie rating, enter in a new value, get a new classification, new value, get a new classification. If the user presses done, the loop ends. And we have an optional challenge down here as well as some of the solution as well. So that's the task here. Let's try this out. I would, before the class ends, you don't have to write this exactly, but maybe write down some steps here like this, so you feel like once you start, you have sort of a process to follow. As these get more and more complex, it's going to be really useful again to be able to have a plan in place before you start coding. You just start throwing loops and prompt and conditional statements at your code, it's gonna start to feel stress. So that's the plan. I guess see when folks, are there any announcements to share before class ends? Seems like a nah. All right.